Hey, hi everyone. I'm Krishna Kumpali, developer advocate at Eden AI. In today's tutorial, we'll explore how to use the text-to-speech API to generate high-quality voice synthesis from text, with, of course, flexibility in the voice selection. We'll cover something like benchmarking to understand which tone is good enough for the project using the Eden AI application. And we'll also learn how to make an API call, and we'll try to understand the fallback providers, how to implement them, and then we'll go through the optional parameters like rate, pitch, volume, etc., including some webhook parameters, how to utilize them. And finally, we'll see how the SSML support is there in the text-to-speech API as well. So by the end of this tutorial, you'll have a clear understanding of how to integrate and optimize the API for your applications. So let's dive in. Before making any API calls, you can benchmark different voice providers using Eden AI's app. For that, just navigate to the Eden AI's platform and then choose text to speech from AI APIs, and then you will be here on this page, right? So on your left, you can see a quick start with text to speech API, which has all the code snippets for Python, JavaScript, and curl. And on your right side, there's a pricing for all the providers currently supported here, and along with the billing unit, right? Um, but let's forget about that for now, and let's go to the testing part because I'm not quite sure which provider I have to choose, right? I don't know which provider is good enough for my project. So for that, it's better if we can, test for now. So so I selected all the providers, and then there are a couple of example responses you can play around with. So if I click on the example response one, so this is the original text, and these are the results. So if we click on the API response, you can see um, some data which we may not need for now. Let's go to the visual part. Yes, this is an audio file that helps us to understand which voice is suitable for our project. Let me play this.
Hello, this is a text-to-speech test. Welcome to Eden AI.
Okay, that's Amazon. And
Hello, this is a text-to-speech test. Welcome to Eden AI.
this is really good. For the API.
Hello, this is a text-to-speech test. Welcome to Eden AI.
Hello, this is a text-to-speech test. Welcome to Eden AI.
I mean, I really liked 11 Labs, even though it's a bit expensive comparatively uh, when you compare it with Google or Amazon. But I really like the quality of it. So I may probably choose 11 Labs. So I just deselect all of them and choose only 11 Labs here. Let me choose a gender. Let me try male, right? And then I'll just launch it. Okay. Let me play.
Hello, this is a text-to-speech test. Welcome to Eden AI.
That's perfect. So this is how you can choose your uh, the voice for your project. And let's go to the API part now. So in order to use the text-to-speech API, you need an API token, right? So when you log in to the Eden AI platform, you can see on the left hand side, you can see the API keys. That's where you can manage all your API keys, create a new one, delete the existing one, right? But by default, when you log in, when you sign up, you'll be provided with one API key, and you can use that API key to authenticate uh, the request, right? So how can we do an API call, right? It's pretty straightforward. And thanks to the Eden AI's platform, there's a code snippet available directly, which you can integrate into your project, right? If your project is based on Python, I mean, if your environment is Python based, like Django, Fast API, or Flask, you can head over to this Python code snippet section, and you can use this complete code into your project directly, right? But let's say if your environment is Node.js, then or any JavaScript based, then you can switch to the JavaScript tab and then choose this code snippet, right? So this is pretty much straightforward implementation, but I'll show how I'll be using this in my project, small project I made, and that will be clearer for to understand, right? So inside the code snippet, let's just see what exactly we have here. Under the header section, we have the bearer token, and the URL is nothing but the endpoint of Eden AI, right? Which uh, provides access to the text-to-speech model. That's where we inference, right? And inside the payload, we have providers, Google, Amazon, and then the language, which is US for now, and then option male or female, the voice type, and the text. This is a test. I mean, this is what uh, probably this is the text we'll be passing to the model, right? And we pass it to using the post request, and then that's how we get the response. I mean, it's pretty much straightforward. Okay, so this is a small project that I made using Fast API as my environment, and I created an endpoint with generate audio, right? So this particular endpoint takes the text, and the response of this endpoint should be the speech. So I used Eden AI's API here. If you can see, this is the Eden AI URL, which is nothing but the endpoint that we have to hit. And then this is the payload, which is pretty much uh, copied from the Eden AI platform code snippet. And the headers, everything is the same from the Eden AI platform. And finally, we pass the response here, the post. It's also the same. So we can use the code snippet in a project like this. We create an endpoint and we use the code snippet here. This probably should explain how we can use the code snippet available. All right, let's start with the body parameters, which are really important for this API. So let's understand what exactly they are. And most of them are pretty self-explanatory, so I may not touch all of them. But let me just go through the significant ones. Something like providers. Providers are nothing but the model providers, right? For example, OpenAI is a provider, and GPT 3.5 or 4.0 is basically a model. So you can choose providers using this providers param, and then something called fallback providers, which are pretty much important, because if provider A fails, we need to have a backup, right? So fallback providers work like a backup. So you can choose up to 5. You just need to provide them as an array. So you can just provide an array of all the providers you have. So the first one fails, it goes to the next one, and that's how it follows the indexing order, right? So fallback providers are pretty much necessary, and then so there won't be any default value as such for them, and everything is like self-explanatory, the text, language, everything. Okay, let's look into this rate. What exactly rate is? Um, it's basically the speed, right? Defines the speed of, I mean, the rate of the speech, right? So if it is -100, that means it's very, very slow. And if it's 100%, it's like very fast, right? So it speeds up by 100% or slows down by 100%, something like that. And then it's the same thing with the volume, the audio volume of the particular speech. And then audio format, so which format you're trying to uh, uh, get the audio, right? Could be MP3 or WAV or something like that. You can choose that. And the default value is null. You can see the default value is null. And so there's something called sampling rate. So what do you mean by sampling rate, right? There's a thumb rule. The higher the sampling rate, the better the quality, right? So you can choose from 0 to it's 0.2 million, I guess. Yeah, it's 200,000. So it defaults to 0, but you can choose till 200,000. But the rate, as you keep on increasing the sampling rate, the processing time takes. So you have to consider that in mind. And finally, the webhooks. These are self-explanatory. So webhook receiver is basically used to send the processed result to the specified webhook, right? And then users webhook parameters are nothing but they are used to add extra parameters to the webhook request. And so finally, the send webhook data is basically, if it is false, the webhook will not contain any data, right? So these are like self-explanatory, as I mentioned, and these play a crucial role in modifying the request and getting the output, the proper output. Okay, let's talk about SSML. So what exactly is SSML? SSML is a kind of markup language called speech synthesis markup language, which allows you to fine-tune the speech output with pauses, emphasis, and also different tones, right? A couple of providers they support this sort of SSML, such as Google, Amazon, IBM, and also Microsoft, right? So let's try implementing this SSML in the API here. The best part is we don't need to call a separate API, or we don't need to provide multiple different methods for this. You can just call the SSML. You can use the SSML script inside the text. So I can show you a quick example of how it works. So this is an example I took from Google. So to speak here, it says something like that, and then I can pause, and it pauses for 3 seconds, and then I can play sound, and something comes up. So this is an example. Probably this may not work because this is an example.com, but sure. So I chose Google and 11 Labs. I'm not sure if the 11 Labs supports, but I chose this, Amazon, and also Microsoft. Then if I just launch it, okay. Okay, perfect. So Amazon has returned an error because I think it's not supported. Okay, and Microsoft has returned an error, it's not supported. Or could be an issue because this is probably for Google. So let's play the Google and see.
Here are SSML samples. I can pause.
Well, it worked.
I can play a sound. Didn't get your MP3 audio file.
Okay, let me try 11 left.
Here are SSML samples. I can pause.
Oh, okay.
I can play a sound. Didn't get your MP3 audio file. I can speak in.
All right. So this is how you can implement SSML into your API, and that's pretty much straightforward and easy to implement, actually. So a quick recap of what we have understood today. We have benchmarked providers' voices before making requests to see which voice is suitable for our project, and then we performed an API call to generate speech. We explored fallback providers for reliability and also explored the other parameters as well. And finally, we used the SSML, how we can implement SSML in our text-to-speech API to fine-tune the speech output. So if you found this tutorial helpful, thank you so much, and see you again.